Like many revolutions, this had a quiet start. Page 55 of the publication Experimental Wireless, January 1931, contains an abstract submitted to the UK Patent Office by A.D. Blumlein and EMI Limited. The action of the ears in determining the direction of a source of sounds depends in part upon phase difference and in part relative intensity. It explained that to reproduce binaural effects in sound transmission, at least 2 directional sensitive microphones are suitably spaced to represent the ears and are then connected to a number of loudspeakers through circuits comprising amplifiers, whereby the relative volume of the loudspeaker output is automatically controlled by the direction of the source of sound relative to the microphones. And the crux, the invention is applicable to radio transmission and reception, and to the recording and reproduction of sounds for talking motion pictures. In addition to the patent, Alan Blumlein created a fully working binaural recording system, demonstrated and installed at Abbey Road Studios in London. Remarkably, it took 25 years for the record industry to implement Alan Blumlein's invention. And a further 40 years after his own demonstration, Dolby Labs produced the first 35mm film with a stereo soundtrack. The realisation of stereo recording and playback is only one of Alan Blumlein's many remarkable inventions and achievements. He holds 128 patents. In the IET's recent E&T review marking the institution's 150th anniversary, it cites Alan Blumlein as the greatest British electronics engineer of the 20th century. I'm Jamie McCarthy from IET Solent, and this is part of a series of events marking 150 years of the IET. And given my own interest in audio and electrical engineering, it is both a great pleasure and privilege to introduce Alan Blumlein's son Simon to present an account of his father's achievements from his own unique perspective. Thank you.
Alan Dar Blumlein was born on the 29th of June 1903 in Hampstead, just round the corner from what was the Abbey Road studio now. He lived for 38 years, and I was 6 when he was killed. His father was Semyon Blumlein. He was born in Offenbach in Germany and was sent to England when he was 15 to get out of national service in Germany because he had French relations and the Franco-German War was on. After doing successful business, he refused to do one of the jobs he was asked to do, jumped on a boat for South Africa, and got to Natal. There he met a minister who had some sons. They befriended him, and they asked him to go to meet the daughter coming back from England, Jessie, my future grandmother, as you'll see. He came over the hill with the brothers either side of him, and my grandmother told me, today, I wrote in my diary, today I've met my future husband. And they had successful business in South Africa, but had to get out because of the Boer War. And Jessie was sent to England, and Alan was born in Hampstead. This is a portrait of my father when he was 10. His education started off in a nursery in Hampstead. It was run by Miss Chataway. For those who know the Chataway runner, she was his aunt, and she also was my godmother. He went on to a series of schools, and by the age of 12, he could hardly read or write. But he already had learnt an awful lot. He was sent to a crammer, and within 1 year, he had got 2 scholarships to 2 different public schools. The school up at Highgate was chosen for him, and although he did very well there, he made my mother in latter years promise if anything happened to him, we would not be sent there because he wasn't happy there and thought it was unsuitable. His great day came when he got into City and Guilds, part of the Imperial University, and he said, "Today is the best day of my life, all engineering." Within 2 years, he'd taken his final exams. He had to take them externally because you weren't allowed to do the course for the internal degree if you hadn't done 4 years. But in 2 years, he got a first-class honours degree in light electrical engineering. There was no electronics in those days. From there, he got a job with Professor Mallet in his telegraphy and telephone laboratory as a demonstrator, but he also worked with the professor and they wrote a paper together. That paper was a new method of high-frequency resistance measurement. And they presented it to the Institution of Electrical Engineers, and they said they could read the paper as long as they corrected the spelling and writing. This they did, and it was given in 1924, and they won a premium with it. This was the first of my father's 2 papers to the IEE, and the first that he won a premium on. From there, he went to Standard Telephone and Cables, and Mac, who ran the part of the telephone and cables that they were joining, didn't want Blumlein to join. Blumlein is basically a Jewish name, and there was anti-Semitism in the works at the time. My father wasn't Jewish. He had me baptized in Christian faith, and he objected, and people told Mac that if you didn't take him into Standard Telephone Cables, you would be missing one of the best engineers in telephony. He went on with Standard and joined the laboratory at the same day as JBK, who became a firm friend. He was his best man and was my godfather. JB had come down via Cambridge, and he'd written something about science, but as he said, I had to train again in the electrical side. But they worked very closely together. While in Standard Telephone and Cables, they sent him ADB to Switzerland and France to lay telephone cables. He didn't physically lay them, but he had to make measurements. And this very poor photograph is of a crocodile locomotive on Swiss Railways then. They still existed when I got married many years later, and I took a photograph of it as well. But the point is that works at 15,000 volts AC, 16 2/3 cycles. To lay cables through the mountains, they had to use the only path there was, and this meant laying cables alongside railway lines. And my father did a lot of measurements on the interference of the AC from onto the telephone lines. But he was appalled at the lack of instruments to use with AC measurements. So he designed his own. This is just one of the pages from the patent, but I won't go into the details there, but to say that it was like a Wheatstone bridge, but it used transformer ratio arms and bifilar winding. Bifilar winding means that you wind two cables onto a core and you can cut out interference. This AC bridge became very accurate, and it could measure capacitance to an attofarad. I won't explain. Capacitance is an electrical unit, and it's quite a large unit, 1 farad. So engineers work in microfarads. And to explain what an attofarad is, it's a microfarad, 10 to the minus 18. From here, he moved into sound. Columbia Records, known as the Graphophone Company, were looking for an engineer to help them design a electrical recording system. Early recording systems, the singer and the orchestra had to play in front of often a very big horn, which the vibrations of the speech and music went down the horn and moved the cutter backwards and forwards while the wax disc went round. But sound, they used electrical system, and Western Electric had bought out this good sound recording. I just say good. And Schoenberg, who was in charge of the engineering at Columbia Graphophone, was looking for such an engineer to do the electrical part of it. There was already a man in the Columbia setup called Holman who did the mechanical, but they needed an electrical engineer. My father went along and said, yes, the sound's very good. I can do it, but I don't think you'll be able to afford my salary. So Schoenberg turned to him and said, well, what is it? And he informed him, and Schoenberg immediately doubled it. So that was my father established in sound engineering. He not only designed the system, but many people said it was better than the Western Electric. And it overcame one of the biggest problems too, because they could use it in Columbia. At that time, every recording they did on Western Electric had to have a stamp, a duty stamp on the 78 disc. So immediately they cut all those royalties to Western Electric. This recording system of his had a microphone called the HB mic. Now, my mother always thought that, and taught me, that HB stood for Hell's Bells, because my father said Hell's Bells and got hot and bothered. But of course, it stood for Holman and Blumlein mic. The moving core microphone went on for use for many years and was still used in 1970 for recording in some studios for piano music. It was thought to be so good. They also made a cutting device to record onto the wax disc and all the electronics that go with it. At this time, there's the disc cutter with 2 engineers manning it. At this time, HMV, who had premises at Hayes, and Columbia Graphophone, they united to form EMI. And that was formed with Columbia Graphophone moving their premises from Petit France in London out to Hayes. And they united the research team in their research building at Hayes. They opened in 1931, and my father's recording system went into HMV's recording studios, which were in Abbey Road. They'd taken an 8-room house in Abbey Road, gutted it and put extensions on to build their studios, and they had to build on extra space to put my father's recording system in. But it was in when Abbey Road started. Now we move on to stereo. In 1931, my father was courting my mother, Doreen Lane, and in the cinema one day, he said, "Look, Doreen, the sound doesn't move across the screen when the actor moves across the screen. I have a system that a blind man sitting where you're sitting could tell exactly where the sound was coming from as the actor moved left to right or right to left." And by the end of 1931, he'd taken out his fantastic patent. It had over 70 claims. It claimed not only stereo for records, but for film, and also it mentioned radio. Another important thing that he wrote into the patent, that although the only 2 recording systems available to him at right angles was the lateral system that we know on discs, on the 78, and a Hill and Dale system, which did the stylus moved up and down. The great thing about this is that those 2 recording systems which were at right angles, and for good stereo sound, you must have one of the cuttings at right angles to the other. There's a famous bit of information, if you do physics, that forces can't work at right angles. But he wrote into this patent that it'd be much better if the groove was cut 45, 6:45, cutting in like that. And that's what happens today. We're now going to see 2 films demonstrating stereo sound.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4,
This
5, 6,
first film
8, 9, 10.
was made in their sound
6, 7, 8,
studio at Hayes,
13, 14, 15, 16, 17, 18,
and it
19,
demonstrates
21, 22,
stereo.
23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Monday,
I hope you can pick out the different speakers.
Friday, Saturday. Monday, Tuesday, Wednesday, Thursday, Friday. Saturday, Sunday, Monday. Tuesday, Wednesday. 1, 2, 3.
Now, these are senior engineers. They haven't got white coats. That's my father doing up his double jacket, and they all go behind the curtain and come out again. And that's my father again, walking across the stage. It's a great privilege that I can see my father all these years after his death. This marvelous film was made from the Central Research Laboratories and I had a job there for a short while later. And you can really hear God's wonderful railway engine going across the screen. A second one will come now. When stereo first came out, somebody made another film like this to demonstrate it. We move into television. This was a great thing for EMI to get into. The directors of EMI decided they would get into it. HMV had done some work on it, but the television that was being transmitted at the time was Baird's television, and Baird was mechanical. He worked by scanning the film or the head of the patient. I call them patients because they had to be made up in very funny colors, and they had to sit very still often as this disc rotated in front of them. But EMI said they would work on electronic television transmissions, and they did it in conjunction with arrangement with RCA in America, that they would exchange information. Anyhow, my father was joined by a lot of other engineers, and the engineers were quite brilliant. They worked on this television together, but my father had a roving job. He would go into one laboratory and say, "How are you getting on?" And they'd say, "Can I help you?" And he would say, "Well, I'm not sure, I'll come back." And they came back with a solution. And he would say sorry, he would use a pipe cleaner to make an animal as a sorry, I got the answer. This happened many, many times. He always smoked a pipe while working, so he had a copious supply of pipe cleaners. This is one of the works that he did in conjunction with one of the other engineers. This is what McGee, a brilliant engineer from Cambridge, was working on, the Emitron camera, which was basically this tube, a cathode ray tube on the right-hand side there, and it shone electrons, fired electrons at the screen, 6 and 7. The image came through, you can see two imitations of lenses in front of the camera there, and the image would be scanned by this. The problem was, they found that the secondary emissions were great from the electrons hitting the screen, and they had to collect them, get them out of the way. And my father came up with the idea of making a mesh that could carry a charge on it to take the electrons away. The mesh shouldn't be seen, of course, by the viewers through the camera. So he made a mesh of 1,000,000 squares to the square inch. And the apparatus that he invented to make it on was very simple. You had a disc that you normally cut records on, and above it was a scribe, a very pointed scribe that cut a groove in the wax. And this scribe was advanced by a screw that turned and advanced 1/1000th of an inch. One person had to pull the lever all the time because you get different movements on the lever and it could lead a dot on somebody's nose. I've seen the apparatus. It's quite simple but effective. Having cut all these lines in grooves in one direction, he rotated the disc by 90 degrees and went through the whole process again. Then you had this disc with 1,000 lines in one direction, grooves, and 1,000 in the other direction. And the system of making gramophone records in those days, which you would, through a series of processes, you would make a silver master. So they made a master of these grooves and then rubbed them away till they went through part of the master there and exposed 1,000,000 holes per square inch. Then, through another system, he coated glass on very thin wire, and you could see the glass wire on the top left-hand figure 1, and get the two pushed together, and you made a mesh like shown in figure 4 with wires going through it. And that was connected up to the circuitry, put where 6 and 7 on the cathode ray tube is shown, and by the circuitry you remove the electrons. problem solved. He had many, many problems like this, and one of them, they had to decide how many lines should be scanned. The ministry had thought that 240 was a good idea. Baird was doing much less at the time, and they stated a minimum of 240 lines. One Sunday morning, he called one or two of his top engineers together, and they met at our house where I was born 2 years later in Ealing, and discussed the problem. And they came out, it's a mathematical reason why the number, but they came out with the idea of having 405 lines. Nobody had made a scanning system that could carry 405 lines on it. They went back and told the director of engineering, Schoenberg. He agreed, and within 2 years, they'd made a complete television system with 405 lines scanning. This was revolutionary in those days, and it went on to be used, 405, for many, many years. I'll talk a little about the launch of the scheme. Baird had a system of scanning a film with 204 lines, and to get the film, he had a camera, and the camera was pointed at the actor or the object. And it was immediately, the film going through the camera was developed. It took 41 seconds, and a massive amount of water. And the BBC at Alexandra Palace, where the studio was set, had great problems with this. I knew the engineer later in life who actually had the problem of installing both the Baird system and the EMI system. And he told me, Simon, it was hell. The water needed for developing the film was terrible. It flooded everywhere. The EMI system, on the other hand, was on the Emitron cameras, could be on dollies and move round as they do today. And EMI demonstrated their system after the Baird system, and they would alternate the systems. And it was meant to be 6 months trial, and the BBC would decide. They decided in 3 months, and EMI Marconi system, Marconi did the aerial and transmission lines. They won the award, and they've had it ever since. I should talk a bit about my father going up the aerial at Alexandra Palace. I'd said that he smoked always when he was working, and he was up the Alexandra Palace, and he dropped the pipe out of his mouth. So he promptly came down again, went into his car, went to the nearest tobacconist, bought a new pipe, drove back, and went up the mast. The other thing I would mention about the transmissions of EMI, before it started, they had an aerial transmission aerial at Hayes, and it was still there in the 50s. And my mother had an EMI receiver in her house. And my father would phone her up and say, Doreen, what can you see today? Can you see the spots on my tie? And she would note accordingly. And so my mother became an untrained electrical engineer, but part of the research team. This is a slide of the long-tailed pear, one of my father's famous inventions. And he invented it because there was a cable from Alexandra Palace in 1937 to photograph the outdoor scenes of King George VI's coronation. I'm very pleased the cable was installed. The idea, my father had it so he make sure that the signal was not non-push-pull. There's a push-pull signal. By the way, the long-tailed pear survives to this day, and non-digital amplifiers, one form or other of it is usually this is the input to the amplifier. Anyhow, the coronation was photographed in the streets. They wouldn't allow it in Westminster Abbey, but my father was up there, but he had 12 people sign that I actually saw the coronation on the 12th of May, 1937. I was 1 year and 1 day old, and I must be now one of the only people who've seen the two British coronations on television. From there, we go on, and we go on to 1938. And this is the big lecture theatre in the Institution of Electrical Engineers. And my father is reading his second paper that he gave on, as you can see, on the EMI system. And he won a second premium for it, and I still own the meter he selected, a small portable AVO meter, and the AC meter that he had in his possession. And those, like other things in his possession, will go to the EMI Trust so that researchers can see them in the future. The war was coming up, and EMI knew this, but they weren't drawn in to radar, or airborne radar, or ground radar. But they had other things to work on, and one of the things they worked on was this is a sound locator for the army. They have two operators listening on headphones, and from the sound, they detect where the aircraft is and its height and things by moving the horns. My father came along, took the signal that went to the earphones, combined them in and put them on a cathode ray tube, having put them through his stereo system, and then the operators could see the marks, not having to wear earphones, but they could see the result on a cathode ray tube. He told my mother that he was very annoyed. Churchill wanted to see him at Gunnersbury Park in Ealing, and for him to demonstrate this piece of equipment. And he said to my mother, I couldn't demonstrate it to at least 11 o'clock or later because Churchill, bless him, he had a sleep after his evening meal, and then he'd get up refreshed, and he went to Gunnersbury Park, and my father demonstrated it. A new thing that EMI had was this 60 megahertz job. It was a private venture, but it was a working radar system. It actually had one transmitter and 3 receivers, and therefore became a bistatic radar system, but it would work. And in the end, my father got permission to go and show it up at the TRE, who were at that time up in Dundee. They were the government engineers, and my father went up and demonstrated it, and they said, we can't take this on, we've got the chain home system. And they said, but we've been trying for years to do an air interception radar so that the enemy plane or signals from it would come up on a screen in front of the fighter pilot. We've got it working at last, and we're on to Mark III, but we can get down to a range of 1,000 feet, but the theoretical minimum range of the system is 400 feet. Could you do anything about it? So my father was there with E.L.C. White, one of his major engineers, and they took the night train from Dundee back to London. But the piece of apparatus that they had to modify was so valuable that my father had it on his bed. He didn't dare put it in with the luggage, and he slept all night with this piece of equipment next to him. Very romantic. But there we are. Within 2 months, he'd modified the equipment so that it would see down to 400 feet. The pilot could see the other pilot by then and knew what to fire at. But not only did EMI do this, but they were granted the contract to make the first batch of Mark IV units. And they were put into Beaufort aircraft first. And if you go to Tangmere, you can see a painting of the first enemy aircraft shot down using the AI system. Recently, some years ago, Professor Russell Burns wrote a book about Churchill and Churchill's reaction to the war and the reaction to his scientific advisor. And he wrote in his book about my father doing the radar system and the speed at which they worked. It would seem possible, he argued, that the slaughter of people in 1940 in London would have been much less had my father been brought in earlier. One of the reasons, of course, is my father had to design systems that worked in television, and the modulators were very similar. So this is a hypothesis, but I got the feeling it's probably true. From here, he went on to other things. I'm showing now a klystron. What is a klystron? It's a transmission valve, and it's used in radar. You've got to transmit a signal out to the plane. It bounces off the plane and returns and is picked up by the receiver of that radar set. Klystrons are reasonably powerful, and 10 centimeter klystrons I worked on in the Air Force, but they wanted to go to shorter wavelengths, and my father developed this 3 centimeter klystron. From here, he went on to work on 10 centimeter and 3 centimeter radar. And this is a delay line that I worked on while I did my national service. This is his delay line in a 10 centimeter radar, and it is different to the other delay lines that they were using, because I won't go into the electronics of it, but delay lines often cut the voltage that's put in on the input by half. And the thyratron is merely a switch at the end of all this apparatus, and it switches the pulse out. All radar uses pulses, and this is my father's speciality, pulses. Now we get on to H2S. H2S was already being thought of, but it was thought that this was so important to Churchill and the scientific boys that Churchill demanded 2 teams to work on H2S. One team was under Bernard Lovell, later to be Sir Bernard Lovell, and the other team, the EMI team, was to be under my father. Both teams worked independently but sent information in between how you're getting on, and they saw each other's works. My father had a klystron as his transmitter, and Lovell had the magnetron. The magnetron, you'll all have a magnetron somewhere in your microwave unit for cooking. It generates heat, and you've got to cool it. But the magnetron that they used was made out of copper, and it was a hunk of copper which was milled, etc. And my father was anxious to see the magnetron working. It was objected to by a lot of political people and scientists. I believe that Churchill's scientists didn't like it. But the point is that if you've got a thyratron in the aircraft, you can put a small charge which, if it went off, wouldn't kill the pilot, etc. But with the magnetron, you'd have to put such a charge on it to blow it up that you'd blow up the plane and everybody on it. They overcame their fear and used it in the end. Anyhow, my father wanted to see the magnetron, and Lovell arranged that a plane would be made available to him. And so on the 7th of June, he went in this plane, the plane that you see there. It was late coming in, and Lovell gave up his seat, and with the crew and other technical people, the plane took off in the end. One or two people got off the plane, and a friend, he became a friend. He cycled down to the officers' mess to get a cup of tea. The plane had left when he came back, and somebody else had taken his place. Anyhow, the plane took off very successfully. A Halifax plane flew over the Bristol Channel. My father was able to see the magnetron and its results in action, and they turned round to come back. Unfortunately, the outer starboard engine caught fire, and the pilot was desperately looking for a space to land the plane, and he was flying low over Herefordshire and saw a field that was likely to be able to land in. They didn't have parachutes, by the way, except for the pilot. The pilot was still trying to land the plane. Just before it landed, the wing dropped off. The fire had spread so much, and results of an investigation made by ex-Rolls-Royce engineers many years later decided it was due to one tappet hadn't been tightened up enough on the engine. There are 48 tappets on that engine. I've seen the crash site. It is appalling. All 11 people on board died. My mother wasn't told till the next day. It was very secret. Churchill immediately slammed a D notice. For those who don't know, a D notice means that the paper can't publish it, the information that they've got. But one paper, evening paper, did and put a small bit in, but it wasn't picked up. Churchill didn't want to please Hitler with the information that such an accident had taken place. Anyhow, I was at school across the Hanger Lane in Ealing, and a parent got me across the road. Usually my mother came and met me. I was 6, as I said. And my mother I caught up with because I got home. The front door was partially open, and there was a strange man on the phone. And there was my mother crying her eyes out on the sofa. The only thing that I had for lunch was mashed potato. And that was my belief. That was the 8th of June. Oh, I should say that Professor Lovell there, that's in his last years, and I went to speak to him again in Jodrell Bank. He's sitting here in his famous laboratories and things, and the control room for that wonderful Jodrell Bank astronomical radio telescope. And this was the last time I met him. I had met him on the 50th anniversary of the crash, and he pulled my brother David and myself aside, and he said, "You do realize, boys, that had your father not made copious notes when he was killed, we'd never have got it off the ground." but in actual fact, the first planes that flew with it had my father's circuitry and also his apparatus, because EMI got the contract. After his death, his inventions went on. This is a circuit taken out of the ACE computer, which Turing designed. The two of them never met, but Turing used my father's long-tailed pair to make the gates, the AND and the NAND gates, and it's full of long-tailed pairs. I don't know how much air was used to cool all those valves, but the ACE computer, when it came out, was the fastest electronic computer in the world. As I said, he was killed when I was 6. This portrait here I'm showing is the only portrait that the family possess of the 4 of us. That's my brother David. He said, "You take David, Doreen, and I'll grab Simon," because I was already quite mischievous and running around. The interesting thing is, this photograph was taken by Folland, the aircraft engineer whose company built later the Folland Gnat, which came the plane used by early Red Arrow demonstrations, and these pilots flew these wonderful things in. And it was very successful for many, many years. And this is the example of one of the interesting friends that my father had. This is a picture from a letter that my father sent to me. My father sent my mother and my brother, not long after that photograph, down to my grandparents in Penzance, Cornwall, well away from the bombing. He stayed in London with JBK and his wife, and they carried on living in Ealing. And this is him, meant to be in the plane and looking out of the bump on the top. I don't know whether you can read it all, but Uncle Thurston, my mother's brother, was in the Duke of Cornwall's Light Infantry, posted on the Isle of Wight, and there they are going around the Isle of Wight. This letter is a letter that he sent to me in 1940. As I said, we'd already gone down there, and he wrote to my mother every day. My mother would sometimes travel up to London, and he'd meet her at Paddington Station. And the first words were, "How much, Doreen?" This referred to the amount of tobacco that she carried. I will try and read this letter to you. My dear Simon, I'm writing to you today instead of Mummy for a change. I'm so glad you are making such lovely things with your Meccano. I should say that I got this Meccano set early because they used it to bribe me to present in August flowers to Madame de Gaulle. The General and Madame de Gaulle were touring for the Free French, and they were going to Newlyn to see a French fisherman who came over. I'm at the... Oh, and also making things with plasticine. I'm at the office now and will stay the night. I have a little folding bed that I put up and are quite comfortable. So he'd work on till 10 o'clock at night and then go to bed. Prior to that, I understand he'd work with some of the other engineers till late, and he would have a meal in the general canteen. But he'd lead the way and sit at the end of the table and they'd chat. Your godfather, Uncle JB, and Auntie Millicent are staying with me. Someday, a long time hence, I hope to be able to come and see you, and then we will build a crane. Give my love to David. Your loving, and he's crossed out his daddy. He got 3 Ds, I think, there. Your loving daddy. His spelling was terrible. It's the only thing I've inherited from him, really. He had 7 spelling mistakes in his last letter to Doreen, his wife, my mother. As you could see along the top, I was already being instructed in cranes, and I still love cranes. And he also did drawings of railways. One of the things, we moved back to Ealing in just before my 6th birthday, and we'd see him sometimes at the weekend. I didn't see him before then because he left before I was up, if he was living at home. And I went to bed before he was back, usually. But he did take me down to the shunting yard at Park Royal and explained hump shunting. For those that don't know, there's a hump. They push the trucks over and they switch the points accordingly to which train it's going to be made up in. And I had to learn about that. He took me down to a fairground, a travelling fairground at Ealing Common, only weeks before he was killed. And he took me to the Speedway. This was a very popular ride in those days. Unlike the Dodgems, which pick up from the floor and the netting under which the Dodgems travel. If you haven't seen it, do go see a Dodgem. The Speedway has to pick up all the electricity needed off the floor. It was a metal floor, and the actual floor had a different metal loops that were oval. One was connected up to one supply and one connected up differently. The whole point being there's a piece of wood between the two that just separate them, and the pickups on the Speedway cars are just smaller than the width of the wood. Thus, no pickup will short between 2 metal pieces. And all this was explained to me, 6 of age, and I think he had in mind for me being electrical engineer. I would say that I failed my entrance to City and Guilds the first time, and they said there's still a place waiting for you. But it was all on his name, and I decided I had to make a name for myself. This shows this wonderful Grammy. It's a technical Grammy, and only one technical Grammy is awarded per year. And in 2017, this was awarded to my father. My son went out to the main Grammy, and then he and his wife very kindly helped my wife and I to New York to receive this technical Grammy. It was a wonderful occasion. It was presented by the president. It's a special award. It's slightly different color to the other Grammys. And I thank the president, then held it up and said, I've waited 75 years for this recognition of my father. Daddy, this is yours. It was the shortest speech, and it got the biggest applause. The other picture is of Abbey Road Studios, and the IEEE of America, that's their electrical institution over there, have milestone awards, and they got on in contact with me and said, we feel there should be a milestone award for your father's stereo. Where do you think we should put it? Well, you will see there's an award on our house already. And I said, well, the only other place is Abbey Road. And so in 2014, we all gathered in a studio in Abbey Road, and the president of the IEEE was passing through London specially so he could come and unveil this plaque for us. It covers the fact that my father went with his stereo recording equipment to the studio where Sir Thomas Beecham was making a mono recording on his equipment installed in the studio, and he made stereo records of his playing of the Jupiter Symphony of Mozart and Noble's jazz band or dance band playing. And you can get recordings of this stereo made in 1934. This is the house in Ealing that I've been talking about, and this is the plaque that went up in 1977. It was the first plaque in Ealing for a blue plaque, and certainly the first blue plaque for an electronic engineer. And it was a wonderful occasion. We all gathered there. The house had long been owned by other people, and they'd even put dormer windows in the attic. But that window on the left is our nursery, and that's where I made my Meccano models while I was back in Ealing. Unfortunately, as I said, my father was killed, and we had to return to Cornwall. I never returned to London till I was 18. This picture is on Deptford Airfield. That was the airfield that plane I showed you took off from. And Paul West, the chief constable, Superman, had to think of a name. He first of all said, well, why don't we name it after old policeman? And somebody said, no, somebody more important was associated with this airfield. And they named it the Alan Blumlein building. The Princess Royal, lovely lady, she came down and unveiled the plaque, which a copy was presented to David and myself for that is in the hall of this building. The Princess Royal came, made a speech, a knowledgeable speech. She's a wonderful lady, and spoke to all 10 members of the Blumlein family there. She then flew off to a third engagement. And nobody knows about this really, except those involved, because the airfield is now securely fenced because West Mercia police use it for their undercover work and terrorist work. But it was a wonderful day. Thank you very much for listening.